Þakka þér fyrir, Bjarni. Ég held við getum tekið undir þau orð að við erum í góðri stöðu til að sækja fram og orku og áliðnaðurinn hefur tekið þátt í framsókninni undanförnum árum og ætlar að gera það áfram, held ég sé alveg örugt. Þá komið að góðum gesti okkar erlendis frá, Daniel Goodman sem markaðsstjóri Alcoa í flugsamgöngum, ætlar að fjalla hvernig álið notað þar og erindi hans ber hið ævintýralega heiti Aerospace Aluminium Empire Strikes Back. Mr. Goodman, the floor is yours. Very welcome to you. And you also have a timer here to help you.
I'll try to respect that. Hi, good morning, everyone. I'm glad to have this because I'm clinically hyperactive, and if I had to just stand there, I'd perish. Anyway, so I'm Dan Goodman. I'm the director of marketing for Alcoa Aerospace. Obviously, from the way I pronounce aluminum, you can tell I'm an American, but I'm based in the UK, outside of Birmingham. We've got a rolling mill in a place called Kitts Green, which most of their business is aerospace. Yes, I've titled this "The Empire Strikes Back." The reason why I've done that will be obvious in a moment. Just a quick refresher about Alcoa overall. Yeah, we've been around a long time, close to 130 years. We've got, last count, about 60,000 employees. And last year we did sales of about 24 billion US. I think we're one of the few, if not maybe the last, of the truly vertically integrated aluminum companies. Upstream, midstream, and downstream. When you first come to Alcoa, the very first thing they show you is a video called "It All Starts with Dirt." And then, and so we do dirt, and then we have lots of midstream, which is our global rolled products division, and then we have downstream products, which are completely fabricated products in several different end markets. Aerospace being, of course, my favorite. Lately, for the past year or so, our CEO has been talking about a transformation strategy at Alcoa. I don't know if it's a transformation so much as a kind of a rejiggering and a concentration that falls into sort of two parts. We're trying to get leaner and meaner upstream. So we've been closing down some of our less efficient smelters in several places around the world. And so we are, in that part of the business, we will be smaller than we've been, but hopefully more competitive and further down the cost curve. That's one half of the strategy. And the other half is some pretty significant investments in our downstream businesses. A lot on, we've made great investments in primarily the aerospace business, which I'm delighted with, and also a major recent investment in automotive, where a lot of the automotive manufacturers are moving much more towards aluminum bodies. And the Ford 150 pickup truck, which is the largest selling personal vehicle in the world, is largely now aluminum. And so this is part of our transformation, lean upstream and major investments in the downstream. Aerospace does lie sort of at the heart of this transformation. These are just 3 acquisitions we've made within the past year. We purchased a company called Firth Rixson, a company called Tital, and very recently, and the deal hasn't even closed yet, it should close in the next couple months, a company called RTI. What you'll notice about this is none of these 3 companies are in the aluminum business. And it's an important point. If you look at what is Alcoa Aerospace, right? If it was a standalone business, it would be about a $5.6 billion entity. And the reason I'm dwelling on this for a moment is when I speak to a lot of aerospace conferences, I get challenged a lot. People say, well, of course you're going to say that aluminum is the best and only material to make airplanes out of because you work for Alcoa, right? You're just a cheerleader for aluminum. And the fact of the matter is no, I'm not. Because for Alcoa Aerospace, I would say, I don't know the exact figure, but it's something like 70% of our revenues are derived from products which are not made out of aluminum. We make a lot of the fan blades for aircraft engines, and those are made out of nickel-based superalloys. We make tons of little fasteners, which are mostly made from high-strength steels and titanium. And then with these acquisitions, these recent acquisitions, we are now probably do as much business in titanium as we do aluminum. And so when I talk to aerospace conferences, which I do, I do have to stress that though I love aluminum, we love lots of metals. We love lots of materials. And I'm not just an apologist for aluminum, and I'm not defensive about aluminum, because me personally, though some of our plants certainly care more about that material than others, as a corporate weenie, right, I don't care what they make airplanes out of, because no matter what materials they choose, we do just fine at the corporate level. Okay, so now onto the sort of the story I wanted to tell. So first of all, what I'm not here to say, right? Not here to criticize our customers, the likes like Boeing and Airbus. We want to kill them sometime, but we of course love them. And I'm not here to necessarily criticize carbon fiber, right? Plastic or CFRP, it's a wonderful material. And like I said before, some of our businesses actually do better when a Boeing and Airbus chooses carbon fiber, because carbon fiber and titanium go hand in hand, right? In order to build an aircraft out of carbon fiber, you need to strengthen it in several key areas. And so carbon fiber and titanium are sort of allied. The more carbon fiber you use, the more titanium you have to use. And so some of our businesses would prefer that airplanes were made out of carbon fiber, right? So that's not what I want to do, but what I do want to concentrate is the bottom two. The first, not so long ago, the obituary for aluminum in aerospace was being written. We were being told, we're dead, the ship has sailed, all planes will be made out of plastic before too long, and thank you, but goodbye. And also, it's a little story about innovation, because what we did was, when faced with this threat, we fought back. And so, let's move on. The actual story starts in around 2003, 2004, when Boeing introduced the Dreamliner, the Boeing 787. And it was radical. It was radical in its choice of materials. You can see a little pie chart where composites represent 50% of the weight of the aircraft. And that was a huge jump. Prior to that, the most you ever saw carbon fiber in an airplane was maybe 5%, 10%. So this wasn't just a little step. This was a major step change in the adoption of carbon fiber in an airplane, right? And you can't argue with success. The 787, if you look at how quickly it sold, it just was like a hockey stick. I mean, people bought these planes in the hundreds several years before the first one was ever even delivered. And so this was a real breakthrough for Boeing, and a real challenge to us in the aluminum aerospace business, right? So that was 2004, right? This is a chart I grabbed from a composites company 3 years later in 2007. And this is what people thought, this was the conventional wisdom. This is what people thought was going to happen. And what you can see is this is the adoption of composites, the percent of composites on the axis, right? And the belief was, the ones in blue are typical, 5%, 10%, 15%. Then you get this huge jump with the 787 in the top right-hand corner. And what people were predicting was the term is the FSA, the future single aisle. Right? These were going to be the replacements for the aircraft we fly on the most, the Boeing 737 and the A320. The prediction back in 2007 was that plane was going to be introduced as early as 2015, in other words, as early as this year. And when it did come out, it was going to be just as carbon fiber intensive as both the 787 and Airbus's answer to the 787, the A350. All right, so they're saying this is the future. This is what it's going to look like, right? In a few years, those two workhorse airplanes are going to be replaced, and they're going to be very carbon fiber intensive. So what really did happen? All right, oh, I'm sorry. It was also portrayed as, to borrow a phrase from the IT industry, a killer app, right? It wasn't just about the weight. It had other characteristics as well. They were arguing it was going to allow planes to be snapped together like Legos, right? Just in 3 days, parts would come in from all over the world, mostly already fabricated or already wired up with electronics. They were just going to snap together like that. There was also a lot of sloppy journalism, to be honest with you. The third bullet down about its efficiency, fuel efficiency coming in large part from composites, is actually wrong. The 787 is approximately 20% more fuel efficient than the aircraft it replaced, the 767. Right? But of that 20% fuel efficiency, about 3/4 of that just comes from new engines. And so there was lots of attribution of all of the benefits of composites. I'm sorry, they were attributing way more of the benefits of the plane to composites than other technologies. And the view that this was it. This was the way planes were going to be built. They were saying, like the 787, the 737 was going to have a composite airplane. Alan Mulally, who was then the CEO of Boeing, was saying, this is now the material of choice, right? And he was saying, okay, maybe we won't see one until, he was giving a sense of the time frame, maybe 2012, around 2015. So he was agreeing with the composites people that this was the future of aircraft design. But that's not what happened. What did happen, right? If you look at the aircraft material choices that were made after the 787, it didn't go that way, right? So first of all, the Airbus A320 and the Boeing 737 decided against a clean sheet. They decided against a brand new design. What they decided instead was, we're going to take the current design and tweak it a bit. We're going to have a derivative aircraft, and it's going to stay metallic. So that's what they call the 737 MAX, is the name for that plane, and the A320neo is the name for that plane. Then you had the Bombardier, the Canadian manufacturer of an aircraft called the C-Series. They said, we're going to stick with aluminum. Then there's a regional jet that the Japanese are building called the MRJ. Interesting about that was they started with a composite design and then changed their minds. So about halfway through, it started with composite wings. Then in 2009, they redesigned it for aluminum wings. And by the way, this is a company that knows a lot about both materials because they build the composite wings. Another division of Mitsubishi builds the composite wings for the 787. So these folks know a lot about both materials and decided to reverse their decision and come back to aluminum. And then finally, these haven't been delivered yet. These are still in development. But China has their own regional jet, and they have their own equivalent to the Boeing 737 and the A320 called the C919. And those two are aluminum intensive. So here the prediction was, it's all going plastic, and it didn't come true. Why didn't it come true? Two reasons. It was one of these. We fought back, right? So the aluminum industry fought back, not just us, but our competitors as well. And composites didn't quite live up to the hype. So when the 787 and the A350 decisions were made back in 2003, 2004, Airbus and Boeing came to us and said, do you have a material that could do this? With a long list of technical specifications. And at that point in time, we had to say, no, we don't. And we didn't. We didn't have a set of alloys and products that really could match the mission requirements that our customers have, right? But we do now, right? And since then, we have spent a lot. We've spent millions both in the lab, right, and in development and in new capital equipment, right, to make sure that we do have an answer, and we do. Part of that answer has been aluminum lithium, okay? Alcoa calls, or actually the industry calls, the aluminum lithium products that we have today third generation aluminum lithium. And that's because the first two generations didn't work out so well, right? It was tried once, didn't live up to the mission requirements, tried twice, didn't cut it. But now what we call the third generation does cut it. I won't bore you with all the specs on the left-hand side, but this is what I meant by we didn't have a material that could meet these kinds of specs with respect to density, stiffness, right? Weight, of course, which is critical for airplanes, maintenance considerations, also improve comfort in terms of cabin pressurization, and lower capital costs. But we do now, right? Our aluminum lithium products meet all of those specifications. And we've put our money where our mouth is. We recently spent well in excess of $100 million on things like a brand new aluminum lithium ingot casting facility, which we inaugurated in late last year in Lafayette, Indiana. At the plant where I work, we spent millions on increasing their capacity in aluminum lithium. And also we have it's called our technical center, but we actually do fabricate aluminum lithium there as well. So we've spent well over $100 million just on new capital, right, to support this new product. In terms of when I said the first generation, the second generation didn't live up to expectations, or our conventional alloys didn't either with respect to mission performance, we didn't have it. If you look at our sort of conventional alloys, our 7000 series, what you see above is one of those tests where they take they take hunks of aluminum and they expose them to a sea coast with lots of salty air, and you look what happens over time, and you can see that those don't look so good. They exfoliated, right? But now our new aluminum lithium 2000 series doesn't do that. So we solve the exfoliation problem. Then when it comes to stress corrosion, which is a big issue in aerospace, you've got wings that bend dramatically with each flight. There's lots of bending and torquing and twisting. Our conventional 7000 series and 2000 series didn't live up to expectations either, but we dramatically improved their ability to withstand stress corrosion. So we think we solved sort of two of the major issues associated with its adoption. And if you look at the demand for aluminum lithium, we're in the early days, so it's just getting started, but this is it's a little old, it's a couple of years old, the third-party prediction of the market for aluminum lithium. It starts with almost next to nothing to close to 40 million pounds before too long. And so we're very, very excited about this product. The other thing I wanted to mention is, like I said, we fought back, but at the same time, carbon fiber hasn't quite lived up to expectations. And I think it's worth a moment sort of explaining this, because it's counterintuitive, right? What's counterintuitive is people in their heads know that carbon fiber is lighter than aluminum. And that's true, right? So if you start off, if I just have a square hunk of carbon fiber and a square hunk of aluminum of equal size, and I was just to hold them in both hands, there's no question the carbon fiber is lighter. It starts off with a 45% advantage in terms of density. But that's not how you build airplanes, right? I'll walk you through this, but by the time you're done, that advantage completely evaporates. 25% of that 45%, right, goes away. It goes away right away because of the fact that CFRP is not orthotropic, right? In other words, it's not strong in all directions. So in order to get the strength that you need in all directions, you've got to lay a layer of CFRP this way, and then one that way, and one this way. You've got to keep on doing these layers and layers and layers in different directions in order to get the strength required, right? You had layers and layers and layers, suddenly you got something that thick, when all you needed, if you made it out of aluminum, was something this thick, right? So it loses a big chunk of that sort of inherent advantage right away. Then the second thing is you've got to take lightning strikes into consideration, because plastic planes, when hit by lightning, that's not a good thing. Bad things happen when a plastic plane gets hit by lightning. You need to figure out a way to dissipate that energy. And to do that, you have to add copper, lots of copper busts, right? So there goes another big chunk of your advantage, because you've had to add a heavier element, which is copper. And like I said before, as with plastic, as plastic goes, so goes titanium. In order to strengthen certain key areas, like where the wing joins to the fuselage, right? These very points where there's lots of stress, you've got to add titanium. So you start off with a 45% advantage in terms of weight and density, but by the time you actually build a real finished structure, a wing, a fuselage, that advantage is gone. And I just stress this, just a little fun fact. I'm not sure, it's not something that the traveling public really wants to know about necessarily, but do you know that every airplane that you fly in will be hit by lightning once a year? A lot of people don't know that. And so the aluminum, when it comes to the dissipation of that energy, is just naturally, physically, far more apt to be able to handle that than plastic. And this was also a key decision, a key decision point for the OEMs. And I've been talking about aluminum lithium, but it's not just really about aluminum lithium. There's an entire value proposition that goes along with adopting aluminum. It's not just the material itself. Our value proposition to our customers is that it also reduces your technical risk. it's less complex, you don't need giant autoclaves, it's easier to detect cracks, and that there were supply chain and all sorts of cost and investment considerations. We were saying if you move to plastic, you got to invest. You got to invest in brand new facilities, brand new plants, brand new equipment, giant, very expensive autoclaves where composites get baked. We were basically saying to them is, you don't need to do that. If you stick with aluminum, it's familiar. We already have a pre-existing infrastructure. So it's not just about the product itself, but it's about the entire value proposition around which the choice to go plastic or metal is made. And finally, so this is sort of the summary that we're here again. Back at 5, 6, 7 years ago, I thought I was going to be out of a job. I thought plastic was taking over, and that I would not get to retirement before that would occur. And now I'll be long retired while aluminum is still being used. That future single aisle that I was talking about probably won't occur until maybe 2030, 2035, before Boeing and Airbus decide to actually go with a brand new airplane to replace those. That's at least 2 more decades, right, of 320s and 737s being made out of aluminum. Right, so that's what I mean by the Neo and Max endorsed the value proposition, and those will be built for at least 20 more years, right? And so that's really it. That when aluminum was being counted out and left for dead, we innovated, CFRP slipped up, and now we're looking at decades of prosperity for aluminum in aerospace. That's it. Thank you.